horizon flattens out. Go ahead, call them up, see what that's about. We can go around in circles trying to find us out. But if you're looking for the truth, got to find it out. NASA can't go to space, so we hit the roof. Get it, hit the roof. And it all came to light with 200 proofs. Now I'm just really sick of people lying to me. So when I tell the truth, don't come crying to me. Pick up the phone, get on the line with me. Line with me. Who you gonna call? Who you gonna call?
And welcome everybody to Globebusters. I am your host, Bob, Xanadude60, and we are back with another great show for you today.
Yes, exactly. And also we are going to see along the presentation, but when you're talking about this gas, this is presented as a dome structure. It's an octahedral molecular geometry that when you put together, you have like a dome. You know, so of course, I am not saying, and nobody, at least that I met in Globebuster, is going to say this is the ultimate truth. Especially when you're trying to explain something that is out there where you don't have direct contact, you cannot going to measure or to touch this, you know, special situation that supposedly is up there. But at least for me,
one question is: does this get hard in any way, or because we? Maybe it is that fluid that the go fast goes into, but does it? Can they make it turn hard?
Yes. Yes, and correct me if I'm wrong, Iru, but I believe that during the presentation, they were talking about, I think it was this gas, and they said that when it gets near the absolute zero, then it starts to become crystalline.
Solidify.
Exactly. Yeah, solidify. Exactly.
And that's why we have absolute zero up there.
Yeah, but it's not just with this gas. The same thing happened with the CO2, for example. I present this gas as something special because it has 6 times more density in the air. The CO2, for example, has only 1.4 more dense than the air. So you know, just 1.4 it's too tiny, the difference. But this gas is 6 times.
That's an interesting comparison, because isn't the air a bunch of different gases? Then how does that work? If the air is a bunch of gases, is it right to compare one gas to air in terms of density, or should it be compared to air as conjunction gases? Sorry. Yeah,
right. The way that works out, obviously, when you're going up higher and higher and higher, you're also starting to get the separation of gases. You get the noble gases at one level, and you keep going up, and then you get into helium, hydrogen. A lot of people say that hydrogen-4 is something that would be a good candidate for this as well. So when you get up that high, the gases, that make up our atmosphere down here at sea level or at 5280, where I'm at in Denver, anything like that, it's a whole different animal when you get up to those altitudes. So continue on, Iru.
Okay. No. I just looking in the other monitor a few things that I have because this is just like a short presentation. I don't have all the things that I really like to share, but let me try to put all together, because it's going to be a really
I think showing that
forward and backwards.
Right. Can you show the rocket and the temperature that it's registering?
Yes.
Okay.
I'm going to start with that. Okay. So something that I came obsessed a few years ago is trying to find the curvature. Maybe, as you know, and maybe you have the same obsession, And, of course, everybody knows that you are not going to find in the ocean shore, because the boat is not disappear beyond the curve. So you're going a little more high, you reach the commercial altitude, you're not going to find there. Then you go to military plane, you're not going to find there. Then you go into balloons, and you're not going to find there. And supposedly you must be found there, but you are not going to. And then I start to study space agencies, you know, but not with the massive rocket, because that is only a Hollywood, show. So I go into the real thing, how you get there for real. And the only way that supposedly it's possible to do is with sounding rockets. And all the space agency and all private companies use only sounding rocket. They don't use big rockets. And you have for free, because the German Space Agency, the Sweden Space Agency, and other private companies, really, low-cost private companies, they put on YouTube their official sounding rockets. Videos, sorry. But something that caught my attention is that the guys from the Go Fast rocket, after creating the Go Fast rocket, they officially create like a company called Up Aerospace. And that company is supported by NASA after the achievement of the Go Fast rocket. In the Go Fast rocket, you can find a few things that are really interesting. Some specialists that the moon and the sun is visible on the horizon at the same time, and supposedly if you go to that date, that is not that supposedly what's going on. Supposedly
kind of like that moon over Australia type of thing.
Exactly, and that is something that a few YouTube channels presented, and that is a really nice thing. But at that time, everyone started talking about that the Go Fast hitting the dome, and you have a lot of videos talking about hitting the dome. And when you start looking, it's not hitting something, and in fact, is the system that the rocket has to try to stabilize and stop the spinning of the rocket, yo-yo the spin. So looking to that, I came across with this new company from the same guys that in 2015 they launched this sounding rocket. This is like an arrow, it's like the symbology behind trying to penetrate the dome with the arc and the arrow. You can find that symbology all over the place in Hollywood movies, in history books, even here from Latin American culture. You know what I'm talking about, right, guys? Yeah.
Yes.
Yeah, the breaking of the dome, Simpsons, and even the Mahabharata. These arrows are very important.
Yes. Yeah. Exactly. So they use this like a tiny rock, a tiny arrow, and this is official video. It's not like something that I made or someone else made. This is official from them, and this is all the data that they put. The mission is deploy Maria. And the names are are really telling the story itself. Maria capsule into space, test the aerodynamics and stability of the payload on re-entry speed up much to
just pointing out that Maria, it's Maria is the seas, right? So it's pointing towards water.
Exactly.
Oh, that's so weird, because what I was thinking, guys, is I don't know if you guys are familiar with the movie Paint Your Wagon, but I was thinking of the song that one of the guys sings in there. They call the wind Mariah. So I was thinking it was the wind. Well, whatever.
But if you listen Santos Bonacci, he explained very well how Maria referred to sea, to water.
It's a Latin root. Maria. It means waters.
Mar.
Mar is
interesting.
Mar for us is sea.
Exactly. The word mar in mar is equal to say sea.
Yeah, in Portuguese and Spanish and Italian and Latin.
Exactly. So that is the first thing that you must be take into consideration. So we're gonna send a sounding rocket to the sea, but that sea is 120 kilometers up. Okay, so that's the first thing. The second thing is that they launched this rocket.
-15.
This is a company, Up Aerospace. And they put this, and I don't know why they do it, because I didn't find any other video footage for any company. It doesn't matter if it was from German, from United States, for private company. This is the only video that I find that they put this data of the supposedly airspeed, altitude, and most important, the outside air temperature.
Yeah, 1 second in, and it's already over 2,000 miles an hour. Now that's a rocket launch, guys. NASA's just some sort of joke.
That is a real rocket launch. Yes, exactly.
Yeah.
Exactly. And this is, like in comparison with the space shuttle or that nonsense rocket, this is just like, like a pencil in terms of the weight.
They are supposed to accelerate 2,000 miles an hour per minute to get to do what they say they're doing, to get to 17,500 miles an hour from zero.
They don't even get close. They don't even before they get to Miko, they're not even coming close. Go ahead, Ben.
Imagine if you're tied to this rocket. What would happen to your body if it shoots like this? If you're tied to it,
you'd be dead.
You'd probably just stick to the ground. I mean,
you'd be dead.
Melted.
Yeah. You couldn't. It'd kill you.
They are supposed to sell.
Yeah. Well, I'm going to continue, and this is really fast.
+5. +10. Burn out. Good burn. Copy, good burn.
Look at the temperature, guys.
Look the temperature.
Temperature
and
is
here,
insane there.
And hear the sound. How the sound start to slow down and eventually disappear.
Yeah, and while you have it there, oh, wait a second, just pause it. See this thing on the side of the rocket? It looks like there's little steel things that are poking out. What is going on with that? I've always tried to figure that out. Why is that doing
magnetic? It looks kind of like magnetic stuff sticking to it. What do you think?
Yes, it's something like that. It reminds me the ferrocell, the ferromagnetic fluids, But I cannot say if this is some kind of metallic sticker that start to, for the temperature of the rocket and the condition of the friction with the air at the beginning, start to
rip apart.
Exactly.
That's possible. Yeah.
That. Yeah. I don't know exactly what's going on. But finally, yeah. Because I don't know if it's moving like like being. If you look, the movement is something like it's moving like a sticker start to break and has this velocity transfer situation. And I'm going to continue.
Yep. Look at that temp go down.
Yes, they activate the spin mechanism.
Yo-yo D-spin.
Yeah, and they jump, of course. They go to but when they cut. Of course, they have the complete video. Why they don't put that? But the nice thing is when they cut and go to this part that supposedly is going to show us the re-entry. Look, the temperature.
Yeah, that's
the speed is almost zero. I mean, it's almost zero in comparison with the initial speed. The altitude is almost 120 kilometers up there. This is in feet. And then this is the outside, because you have the oil temperature, you have the ice zone, as they call here, and this is the outside temperature. So, I mean, and keep decreasing.
Do you have any estimate of how long they cut off?
No, I don't. But I assume if I compare with the German space agency that they send this sounding rocket, could be about 4 to 5 minutes, because they say that when you reach with this tiny rocket, when you reach the 120 kilometers, you're gonna have 6 minutes of microgravity. Supposedly, right. They call microgravity, right?
One thing to look might be, at the cut, the moment of the cut, the difference between the airspeed in the 2 meters before and after the cut, and the altitude, and the temperature, everything, of course. But that will give us, a sense of what has transpired. The change, at least from the airspeed, because it got slow and now it's accelerating again, and it's going down.
Yeah, it's not. Yes, it's not really even in a parabolic arc either, is it, Eero?
No.
That's the thing that's really puzzling. It's like, how can it be in microgravity when, first of all, the gravity at that particular elevation is not supposed to be all that different, maybe right around 9.3 meters per second squared up at that elevation. So how can it be experiencing microgravity if it's not in a parabolic arc, right? What is it up there that is causing it to be in this so-called microgravity? And yet it's apparent that it floats. You know, that's one of the things that Brian Mully, you know, latched
because
onto.
to be accelerating and falling, right? That's the microgravity thing, is a state of falling and being at a very high speed. And obviously none of that's happening. It's in low speed and it's floating somehow in some kind of fluid.
And supposedly, and you know, up to 80 kilometers, we have the less temperature. And after the 80 kilometers, we're going to enter into the thermosphere that supposedly going to reach, you know, 15,000
1500 Celsius.
Yeah, 1500 exactly. So what is exactly that moment that the rocket is going to start to burn, you know, or at least heat a little bit, you know, not burn because it's not oxygen out there, but I mean, this temperature at 120 kilometers.
That's pretty close to absolute zero.
It's insane.
It's insane, exactly. So well, let me just keep playing this. Oh, I'm gonna leave altogether. Sorry, guys, because if I go in back, it's going to kill the software.
Okay, no worries.
Minus 15. Plus 5. Plus 10. Burn out. Good burn. Copy, good burn.
That's where it sounds like it's hitting water. You can hear that really strange sound. Like, you know, the astronauts when they're in the swimming pool.
Yes, exactly.
Yeah. That's very
So there you have the temperature. And, you know, this is in Spanish, but it says absolute zero. You know,
so
it's
close.
Almost the same thing.
Yeah, 3 degrees.
And then, and sorry because this is not translated, but here I present just an official article talking about the superfluidity and, you know, how this material, these gases start behave really, really weird when you talk about the helium-4, helium-3, CO2, hexafluoride, you know, all these components that are gases. Of course, that is the really trinity. You know, the water is like the really trinity. You know, you have gas, liquid, and solid in the same material, and that is something, you know, people didn't think about it. You know, how strange is the water itself? It's like a superhero itself. I mean, it's a material that has these three properties, like, you know, and you drinking and you put ice on the martini and you think that, oh, that's just, you know, just common sense, and, you know, everybody can do that, you know. And you know, when you start looking from outside the system and you see, let's do and create some water from the scratch, you as a god, if you want to, you know. What? I mean, you know, it's a really amazing thing. The water itself is really amazing. So when you put this material in this different temperature, the key is the temperature.
Yeah.
Yes.
They
start taking on like superconductive properties. And the interesting thing that I thought, and I don't know if you have that clip here, was when at those temperatures, water or that substance started passing right through solid objects.
Exactly, and I have it.
Was bizarre. And yeah, show that, Eero, because this is trippy.
Yeah. So what we need to take into consideration from this first part of the presentation is that we have a rocket that confirmed at least that up there the temperature is almost 0 degrees.
Yeah.
Okay,
absolute
that
zero.
is the exact absolute zero. Exactly. So, sorry, absolute zero or near to absolute zero. The other thing that you need to put together is, well, what happened to gases at that temperature? And what happened at that temperature is going to enter into some strange behavior. One of those strange behavior is the superfluidity. Okay? So that is the first thing that you take into consideration for this first part presentation. Then, what is a superfluidity? Well, let's take a look.
There's one thing, if it doesn't have viscosity, should it be behaving the way it is there, where it seems to kind of float? Or is this just, do you know what I'm saying?
Yeah, well, yeah.
Yep.
Yeah, actually, well, yeah, let him play this, and
Okay.
I think we can go from there. Go ahead, Eero.
Okay, let me just go from the beginning.
Okay, here we go.
There were more surprises ahead. In the 1930s, another strange phenomenon was observed at even lower temperatures. This rapidly evaporating liquid helium cools until at 2 degrees above absolute zero, a dramatic transformation takes place.
Suddenly, you see that the bubbling stops and that the surface of the liquid helium is completely still. The temperature is actually being lowered even further now, but nothing particular is happening. Well, this is really one of the great phenomenon in 20th century physics.
The liquid helium had turned into a superfluid, which displays some really odd properties.
Here I have a beaker with an unglazed ceramic bottom of ultrafine porosity.
Ordinarily, this container with tiny pores can hold liquid helium. But the moment the helium turns superfluid, it leaks through.
We call this kind of flow a superflow.
Superfluid helium can do things we might have believed impossible. It appears to defy gravity. A thin film can climb walls and escape its container.
Why he talks about gravity? That if we are talking about densities, I mean, why gravity? You know, that's
some sort of magnetic. Isn't it a magnetic thing that might be pulling it around? Sorry.
Right.
So you know, or less viscosity. Let me just finish. I'm gonna finish the video, so everything is okay.
This is because a superfluid has zero viscosity. It can even produce a frictionless fountain, one that never stops flowing. Superfluidity and superconductivity were baffling concepts for scientists. New radical theories were needed to explain them.
Okay, so from here we have like other two components that to explain our behavior that we observe up in the sky, and this is just my point of view, okay? But here we have zero viscosity, zero friction, zero index of refraction, and for having this condition you must have absolute zero temperature. So we have this condition up there. Well, that rocket shows something that could be possible. We have gases up there. Yes, we have gases up there, and if we have gases at that temperature, that gases must be entered in these conditions. Okay, and so what happened to electromagnetic field when you enter in this absolute zero and these conditions? And that is the next video, but if you want to comment first of all on this part.
Well, I would say that the electromagnetic field would become stronger because that's what seems to happen, at least when they supercool things down here on Earth. However, up there, I'm not sure, and they're not getting anywhere near that. But the thing that I find interesting is that it is fluidic. It doesn't seem to have any friction. And when you observe what that rocket did and the sounds that it made, it sounded like it hit some sort of a liquid, and then it suspended, and it exhibited anti-gravity type behavior, like microgravity, as they were saying. And that's very interesting. And what I find even more interesting is that I think at some point here you were talking about when it continues getting colder, then these gases, these liquids turn into crystalline form, which of course would kind of go right along with the crystalline description in the Bible of the firmament, right? So,
because the gas when you have gas, you have like a reverse behavior. It's first is a gas, so if you start to hot, that gas is going to evaporate and disappear, if you want to see it that way. But if you have a gas and start cooling down, the gas is going to turn into liquid. And after a liquid, of course, what happens when the liquid is cooling down? It became an ice.
Yep, crystallizes.
Exactly. Crystallizes, exactly. So,
and we are seeing all of those behaviors as the temperature drops. And, to the point, if it continues on, then it turns into an absolute solid structure, which, of course, MIT, CSU has confirmed that there is something that appears to be absolute glass-like. A solid structure is how it is described, et cetera, et cetera, et cetera. This is absolutely amazing how all of this stuff seems to be panning out right here in this one demonstration.
The question, Edu, like if these rockets then, these are entering these fluid state that we're seeing this happening, it's super fluidic, and then there is the magnetic field and so on. Then what about those Dominic missiles and those bombs? Because they're exploding, the rockets are exploding against something, we see it spreading. Do you think it's going beyond, it has to be going beyond this point that these sounding rockets are going?
No? Well, I don't believe because I don't want to lose the story of this presentation. So then we can take that when I presented the gas itself, if you don't mind, Rodrigo.
Yeah.
Right.
Because we have all these conditions. So quantum locking. Why I'm talking about quantum locking? Because all the planets or the luminaries that we look up there, they, you can say that they only present one phases, like the moon, for example. They are rotating in cycles, so they never change the cycle along the way, from the creation to our days. So for that conditions happen, you don't need to have friction up there. Because if you have friction, eventually you're going to stop. So when the modern science start to talk about the quantum locking, they need to go really down in temperature, because it's not, you are not going to have this quantum locking. And let me just reset the PowerPoint because it's autosave, and because this document is a little heavier, it's going to be more quickly to reset the PowerPoint and wait to the autosave.
Even Newton observed that there was no friction, and that's how he came up with the idea of vacuum.
Well,
that's how he tried to explain that the Earth has to be spinning against nothing, otherwise it would stop. Exactly what you said, but he didn't know about any of these things that we're talking about.
No,
now.
Of course we are better than Newton, man. Of course.
The phenomenon you saw here for a brief moment is called quantum levitation and quantum locking. And the object that was levitating here is called a superconductor. Superconductivity is a quantum state of the matter, and it occurs only below a certain critical temperature. So a superconductor is defined by two properties. The first is zero electrical resistance, and the second is the expulsion of magnetic field from the interior of the superconductor. Inside the superconductor, there are no collisions, so there is no energy dissipation. It's quite remarkable. Think about it.
Yeah, it is.
In classical physics, there is always some friction, some energy loss, but not here, because it is a quantum effect. But that's not all, because superconductors don't like magnetic field. The combination of both effects, the expulsion of magnetic field and zero electrical resistance, is exactly a superconductor.
Ooh, so I was wrong.
How this works. I have here a superconductor, and when I place it on top of a regular magnet, it just stays locked in midair. Now, this is not just levitation, it's not just repulsion. I can rearrange the fluxons and it will be locked in this new configuration, like this, or move it slightly to the right or to the left. Now, of course, I can turn it upside down and it will remain locked. For example, I can make a large circular rail here. It moves freely. And again, that's not all. I can adjust its position like this and rotate, and it freely moves in this new position. And I can even try a new thing. And hopefully, if I did it correctly, it stays suspended. You see, it's quantum locking, not levitation.
So I present this like we have a more, things to consider when we are analyzing this these luminaries and that kind of thing. First of all, a magnet could be oriented all the time to the same phase, like a moon, for example, does with us. If you have a center magnetic field that in our plane of existence, we have that kind of condition, perhaps, right? Like the Mont Meru, or these kind of setups. I'm just talking about this setup, like when you have a magnetic center, and of course you're gonna have one direction spin. That's the property that you're gonna, achieve. If you have one center magnetic force that drive everything around it. So you know where I'm going with this, right? So we have superconductivity, that's the real superheroes, superconductivity, super locking, quantum locking, the superfluidity, the lower temperature.
That's one of the things that gets me. Why do they have to just try to explain this as quantum locking, quantum effect? He repeats that. It's like magic. The way he repeats is it's putting you on a spell. Why is he pushing this? It seems to be just electromagnetic stuff. It seems to be just basic chemistry that we were looking at before.
Yeah, and in fact, they talk about fluxons. Well, show me a particle of fluxon, please.
Fluxons.
I mean, fluxons, the gravitons, because they implied the word quantum, it's implied quantified. So you need to use this terminology to put particles in the minds of the people. So if you are talking about, quantum locking, well, where is the particle that take that into, functionally behavior? Well, it's a fluxon. Well, show me a fluxon. No, it's too small. Okay, it's a field,
theoretical.
and it's exactly. We don't know what's going on at that sizes. If you want
it's
to,
some sort of, would you say, is a resonant field that's. It's almost like alive. It's almost like magnetism is almost alive. It's constantly, it has a kind of spin usually. And that's something you can observe. So, when you go up into the atmosphere and you study in the geological way, something remarkable is that it doesn't matter how much CO2 we are trying to fight, because, for example, the same amount of these gases, the sulfur hexachloride, is going to equivalent 100,000 times more than the CO2. So trying to make that image in your mind. What did you say? It does what more than CO2? It's heavier?
No, I'm going to say in Spanish and you translate. La misma cantidad de CO2 equivale 20.000 veces la de el hexafluoruro de azufre.
So 20,000 times the same quantity of CO2. It's the same. It's equivalent to 20,000 times the amount of this.
Yes, the global warming effect, it's 20,000 times more the hexafluoride sulfur gas than the CO2.
Right.
And that is official
it locks
data.
Things in, probably because it creates the wall kind of thing, the dome.
Exactly. And that is official thing. This is take from official textbooks and articles and things like that. So, for example, anytime that a volcano make eruptions, it injects all this gas, which one of the most gas presence in the volcano eruptions, like you can read here, of course it's in Spanish, but you can find the same equivalent in English, is not the neon gas or the oxygen or the hydrogen. It's
sulfur hexachloride.
Yeah, exactly.
Wow.
So if you go to the and I like to relate this with pillars of the creation and things like that. When you go a little more symbology, you have these pillars that it's like they keep the dome or this situation up there. Maintain it. Yes, exactly. But that is just a poetic way of presenting this. Okay, but the thing is, we have that gas up there. It's not just 20,000 times more, heavier or more
denser.
Not denser. The global warming effect than the CO2. Right. And remember Bill Neal talking about that the CO2 create like a dome, and he said it on the on that TV show that. He presented the CO2 warming effect as a dome and as a closed system.
Who did it? Bill Nye, you say? Bill Nye?
Bill Nye, yeah.
Right.
Russian Beat presented that video like a year ago. So we have this presence of that gas. So what is this gas has, like particular than the other gases up there? Well, first of all, it's going to be 5 times more dense than the air itself. It's going to be a thermal insulator, non-flammable, reduce the sound frequency, is going to not produce refractive index, so it's like invisible, is colorless and odorless, and also is going to kill every kind of electrical standard behavior. So let's go into see that in action. First of all, this, for example, is like this container is filled with this gas, and this guy is going to drop just a tiny tinfoil boat concept there, but that floating is real. And I present like an overlay animation that you can see what is going on up there. Is react of course like a fluid, but when you start looking into this kind of presentation, you can clearly see how reacts as a liquid, and this is standard pressure and standard temperature. Okay. Because that is just here on Earth, but you can see how behave. Okay.
So essentially, the volcanoes are ejecting this way high up, nearly to the thermosphere, and at that point they start taking on superconductive type of properties, and everything changes when you get up to that altitude and that temperature.
Yes, that is the idea. So we have this density capability. Then you have the thermal insulator that, for example, this guy is gonna took this tinfoil box filled with the gas, and he's going to drop over candles, and you can see how the gradient spread is, turn down the candles, and then
fell on it.
Yeah, and then when this guy put the electricity inside the container with the gas, immediately it's going to turn off. But look at the red. Yeah, it kills it, but it's still on because the red light is still on. Yeah. Exactly.
Yeah, it just stops. It just stops it. In other words, what it's acting like is it has a much higher dielectric constant than air does, and it's literally shutting down the spark gap in between the two conductors there. So it's very
Yes,
insulative, is what you're saying. It has very high insulative qualities.
Exactly, and in fact, here from this French documentary talking about the hexafluoride gas, for example, here you can see with fire, when it's put, it's immediately turned off, but the gas itself, the monoxide, or I don't know what is the gas that left this burn, is on the top, because the other gas is more dense, so it's down.
Doesn't
you cannot
come into it.
Exactly. So you
That's
have
crazy.
a lot of document. You have a lot of documentary. Yeah. For example, here you have at 20 degrees, standard temperature, you're going to have as a gas. But when you start cooling down, it's going to be a liquid. And if you keep going down, it's going to convert into crystal or ice or more solid behavior. Okay? So this is a long documentary. You can clearly see here how the gas starts increasing and shoot down the electricity and jumps immediately to the next level of possibility. And after a certain point, you don't going to have any more electricity. That is why it's used in the electrical industry as isolator. Okay, for all these properties itself. But we have in the atmosphere, we have a lot of this gas in our atmosphere. That is the crazy thing. So when you start going and trying to put all together, this is the sound effects, like change the frequency, and it's like the same behavior when you see this rocket changing the sound. When it enters in this condition, we are going to hear right now. Look, the expansion of the fire and
wow.
That
just goes to show you that NASA can't get through that crap either. I mean, there's a dead giveaway for you, folks. There is a dead giveaway for you. Just another NASA lie exposed. Awesome.
It's interesting too that on that video there, when it's stopping to the spin, it looks like the Earth itself is getting flatter and flatter as it goes up.
Yeah, and I know, and I don't correct its lens. This is a fisheye lens, and I didn't correct it. I leave as original it is. Okay, so that keep that in mind. But right now, supposedly this rocket reached the 120 kilometers. They go into this microgravity, so they cut that part of the video and they only show us when it's going to re-entry. But something that is interesting to take into consideration is that, first of all, we have liquid stick to the side of the rocket up there with the super thermosphere temperature. It's a little strange because, after all, we never see supposedly the spacewalk showing us experiment that the astronauts say, I'm going to release water right now in outer space to see what happened. Nobody showed us. And that will be the most, unvaluable experiment out there. What happened with liquid in the vacuum of space? Why they don't show that?
Well, great question. Great point. So we have or fire trying to start fire up there, whatever. But we have this kind of not just liquid, it's like
ice on the side of the rocket. And then we have this behavior like it's like floating. It's not in microgravity or some kind of levitated behavior.
It's like a buoyant. It's like a buoyant behavior. Like it's bobbing up and down. Yeah.
Exactly. And the other thing that's
the sudden change, right?
Yes, is how it's self-auto-oriented after passing through this state of the fluidity.
Yes.
Because right now the rocket is
This is that Brian Mullen made the exact same observation, and so did I. That is astounding, how it does it. It reorients itself. Like something is literally manipulating it, like it's floating. Really?
Yes.
It's
yeah. So you have, and listen the sound. The sound start to receive again air. So that right now is just in the random position, and then it's going to self-oriented without any kind of. And look, the water that is coming from here. What is that water?
What is that?
And then I assume that this rocket have a heavy part in some, for example, in this part is going to have more equipment, for example, attached to this part of the rocket, and that is why it's auto-oriented.
Okay.
Because it's going to start to reset. Not reset. I'm sorry for my English right now, but you know what I mean. I mean, when you are underwater, you always trying to self-oriented based on densities that you have in your, equipment or whatever. So when you go up there, I don't know how it's behaved, that self-oriented, but it's like the rocket is just lost his orientation. And when it entered in our standard conditions, everything reset and start working again and finds where is down, where is up, where is size.
Finds it. Yeah, it's gradual as well. As it goes towards that state.
Yes. And the sound itself, and then it's gradually, start to have friction and blah blah blah. This is another one. This is for the same company. It's called Space Sailors. They send this rocket, reach the same altitude, and behave the same way. And when it's re-entry to our standard atmosphere, it's going to reorient it. It's going to behave like they are jumping on liquid, or taking out. It's like a boat, going really fast on water, like a sport boat. Then hit the ground and stop. And this is for comparison purposes. This is a different rockets, and you can clearly see how they all behave the same way. They are like levitated and then enter to another state of fluidity or whatever you want to call it, and self-oriented. They know where is down, where is up, automatically without
Yeah, they take on buoyant properties and act like they're floating. That's exactly what it looks like.
Yes,
that's
I just
astounding.
Do you remember that Hennessy? Do you remember that Hennessy commercial where the balloon pops up through the liquid? Anyway, just to really does seem like that's exactly what they're describing.
And that's something that could happen. Is like this is the barrier, this is a gradient where this condition starts and the standard conditions end. And of course, you're going to have this microgravity, quote unquote. And then when the rocket enters in our standard atmosphere, is going to hit the other property, the other density, the other fluidity, and start spinning, because you're going to have friction. You are going to have again this loss of energy and all the behavior that there is not a quantum, quote unquote, state out there. Right. So for putting all together, we have all these properties up there to have floating luminaries or orbiting celestial bodies showing us the same phase all the time without losing any kind of energy to lose their cycle. So we have all these properties to not getting out, first of all, with human technology. Because imagine something that I trying to say is, will be really amazing to create a rocket, like a go fast rocket, independent rocket, send it up there and put outside of the rocket a few instruments, like for example, like something that produce electricity, and see if the electricity up there could, be started, or put a fan instead.
Well, I think we already know the answer to that, Eru, just by looking at the behavior of sprites, and how they discharge up and they literally flatten out when they hit that level.
Yes,
so
man,
I think there you go.
Yeah, and that is the next part of the presentation.
and this, I was wondering what does, because the superfluidic state has no friction, like we were talking about, but the rocket acts as if it's floating. Does it have anything to do with voltage at all? Well, this supposedly also insulates, but then what about electromagnetism? Is it also completely inexistent inside the superfluid? And why does
it's get more power,
stronger? Okay, so that explains the buoyancy that you see. What we may call, like, it acts as if it's buoyant, but because it's in a superfluid, then maybe its magnetism acts on it somehow. Something happens there.
Yeah, but take this into consideration. We are only scout only 120 kilometers, but we don't know what happened more up. Maybe there is a gradient, and after a certain point, you change again conditions. And the things start behave completely different, So we don't know, because we cannot. That is why I say, why don't create a rocket with like a really big fan on the bottom, and we activate it and trying to behave more like a submarine thing, not trying to ignition fire to keep going up there.
Propeller, you mean, like in the back that turns?
Yeah, exactly.
I have to wonder what sulfur hexafluoride does, in the near superconductive state, or superfluid state, excuse me, and even when it supposedly starts turning crystalline, what that does optically to things, and if it could cause something like that phenomenon we were seeing with the parabola, the parabolic dish and the apparent position of things.
Yeah, well, that will be. In fact, you can achieve Can you repeat so I learn how to pronounce that?
The parabola?
No, the hexafluoride.
Sulfur hexafluoride.
Okay, that thing.
Sulfur,
you can buy it.
Right, sulfur hexafluoride.
Yeah, sulfur
you'll get it.
Fluoride. Yeah, you can buy it and experiment. I showed these guys on their own labs, playing with this gas. So it's not something that you are not going to, it's not plutonium, it's something like that. I mean, you can buy it. And, just for close the presentation, you talk about the sprites. And of course, I really think about it, because you have this massive discharge of electricity that it's just going down and not up, because it's something there that stops that electricity to go up. That is the first thing that I think about it. And then you have,
you can almost see a wave from the top of that fluid, almost as it fades away. If you know what I'm saying?
You see this gas behavior, like I show when the guy puts the paper with fire into this gas, and go, and you have the same behavior. You have this tiny gradient where just produce this gas but stop immediately because it's not keeping the penetration. Then you have this dome, this clary dome thing, in terms of polarity. Then we have all this electricity behavior in our sky. Then you have all the ancient symbology with the black sun, the moon, the sun, and the dragon, the serpent, represent the aurora borealis. That is why it's green color. The serpent, the dragon represent the green color. You're gonna have in a lot of culture that talks about the white dress, it's the moon, the yellow part is the sun, the black part is the black sun, and of course the wings, it's in color green because represent this snaky behavior of the aurora borealis, which is, for me at least, is the matrix information. That is why matrix use the green color of all the letters coming down. And then if you keep going in this symbology way of looking at, you have all this representation in the ancient cultures that represent, this kind of tool is more like representing the power of electricity and magnetism than just a simple tool.
Yeah, that's kind of like Zeus's thunderbolt. Is what that looks
exactly.
like. Actually, that's what it says. Okay, I just read it.
Exactly. You're gonna find these pillars. These pillars in Egyptian culture or Greek culture. This digit column is like a synthesis of the Phi letter that represent the magnetic field. Closing together. Representing like this closed system. So you're going to have these pillars also in the cosmology of the Egyptian, showing the dome.
Several planes almost coming out of that idea there, that they're just showing this pillar. Right? It's almost like that there's 4 levels over there as well.
Yeah, the
Djed
column and the pillars is something that Cami and Zach, Good Times for All, and my wife Cami, were kind of focused on in their presentation, and how they apply magnetically to this construct. So this is so cool. This is all kind of coming together.
Yeah, even the modern high voltage insulator has the same thing as the columns.
Right.
In our modern times, we can see the same thing. We can see, of course, all these behavior,
chips,
the chips representation. We can see the Nikola Tesla electric oscillator, like
another
thing. I mean,
another thing, if you come back just a few slides, there's a similarity between the Egyptian cosmology and the tree of life in the center of the dome there, that figure there, and the slide before this one with the ancient glyphs on rocks, right? I think it's the one right before this one as well.
This one?
No, the slide before this one. That one. See those figures there? The kind of frog, these ancient.
Those things, all over the place.
Yeah.
Those are actually plasma patterns.
Yeah, the plasma pattern. Yeah, the plasma pattern is also maybe represented in the Egyptian cosmology at the center, with where the tree of life would be, where the North Pole and Mount Meru would be in that representation, because of the arms outstretched, just like that kind of froggy figure.
The real thing, when you're trying to put all this together, is that we have been deceived and reset our histories so many times that we found, because I always ask, show me the mathematical numbers or formula to build up the pyramids, because if you don't have the modern mathematical equations to build all these magnificent supposedly rockets and buildings,
it's by chance.
Exactly.
They're lucky. They're lucky.
They're lucky because I don't see even one equation of the pyramids of any
How are they doing
civilization. How they doing it? Exactly.
They don't need to have Arabic numbers to have mathematics. That's one of the things.
Exactly. So when you start to put all this together, it's really complex, because nobody here is an expert. But when you start to put all this together, the zero viscosity, zero friction, all based on zero temperature, and then the electromagnetic field, the quantum levitation, the rocket that show us that property up in the cold firmament, quote unquote. So that is why I trying to say we can have a dome in terms of the symbology. The word dome is mean house, is mean dominator, is mean few things. Depends in the culture you're gonna go. But the thing is, we have a physical properties to explain that if we have that temperature and that gases and keep getting cooler, we're gonna have a container based on physical properties. Not just because, after all, when I see out there all the magnificence of the nature that is created in a biological way, why this super intelligent is going to create some kind of glass metal structure that is not nature way, if you think. Nobody's you don't have glass.
In other words, you're saying we don't need this mechanical thing, like crude mechanical buildings like men would use. Yeah, I get. You know what? I get it, Iru, and that honestly makes a lot more sense to me. It's accomplishing essentially the same thing, but taking the utter crudeness of our methodologies out of it and adding a more divine touch, if you will, which is amazing. Wow,
it's almost like I was just going to say, it's almost like the matter. It's the whole creation is in the nature of matter itself as it progresses in these levels of density, that it generates this realm. It's incredible. Instead of something constructed, right? It's just part of nature itself. It's quite incredible. Yeah. That I guess
astounding. Mm-hmm. So beautiful presentation, Iru. Wow.
Thank you.
I'm blown away.
Awesome.
Thank you. And I know that, I have also a lot of electrical things presenting as electrical earthquakes, and, a lot of things. So I hope the people out there understand, because you, Bob, has like antibody for my English. So that is why you understand me. But I know as long the presentation goes, I start to mess around with English.
Sounds
words.
really good. I think it was very easy to follow. Iru, the one question for you, so you're talking about layers going up, going down. What's the deal?
Well, I don't know what is going down, but we have experience. We can have things that happen in our underground based on electricity, like earthquakes and secondary bounces and things like that. For example, the Thunderbolt project guys, they show a lot of experiment that you can conduct electricity underneath. I mean, you see this here, and you assume that it's only happened in this part of the jar, right?
Uh-huh.
But no, it's also happening underneath this.
It's getting in it.
Yeah, you can see here in this side view. Oof. So you can have a lot of explanation based on electricity. For earthquakes, for comets, for moon craters. I have a complete presentation based on the electrical universe. Not just explanation, but also to show the behavior on labs.
Some people in Brazil are saying that the plasma coming in and leaking from the top and hitting the earth could generate like metal ores, like veins of steel, or not steel, of iron, that have been found to be not oxidized, which is very odd. They cannot, apparently the ball model cannot explain why can you have these big pieces of iron with no oxidation in their
one thing, Rodrigo, that you mentioned going down, and we had a guest, his name was Chris Monk Sele. Right. And he talked about, when they were digging down, that when they hit this 8 or 9 mile limit down, that they were actually coming into some sort of slurry that because of the pressure that's on it, it caused it to change state and become harder than anything that mankind had ever encountered. And I don't want to screw it up by misdescribing it, but I'll try and pull that out maybe my next show, his exact description of its chemical composition. But I do remember him saying that it came out in some form of a slurry when they relieved the pressure off of it, which I found very interesting. And again, this would be consistent with this type of natural type of creation, right? In other words, how God would create this rather than, crude man.
And remember that for creating stars, artificial, quote unquote, stars, you also need a liquid. You also need a medium to create this luminescence point of light. And I have
totally
it
do it. At the very least, you can totally do that. That's what
exactly.
Right?
And then you have the total field that represent, our magnetic field of existence, and you can prove that with ferrocells and magnetic and magnets, underneath this ferrocell to see really the torus field of a magnetic field. So it's all there.
Incredible.
It's all there. The problem is that when Newton and all these guys, occultist guys, came across trying to explain what happened up there, they don't, at that time when Newton supposedly get born and develop his theories, they don't know nothing about electricity. So they present a model. They present a model without taking into consideration electricity. So
no, they even know it's there. Yeah,
exactly. So 300 years later, Huygens, Ampere, all these guys came across with electricity, and they say, well, we can explain everything with electricity, but we have been the last 300 years trying to kill people, trying to put this concept of gravity in his mind, and now we have all the answer via electricity and magnetism. So what we're gonna do? I mean, so it's a crazy world. Yeah,
that's awesome.
But they had to keep gravity because of the ball, right?
Yes.
Well, yes and no. I mean, and obviously we have a little different opinion on what gravity is and how it manifests. But regardless, I mean, because in my opinion, we need gravity just as much in the flat Earth as you do on a ball Earth. The problem with the way that they use it in the ball Earth cosmology or the heliocentric cosmology is, they're saying, well, this incredibly weak force is, somehow powerful enough to keep the Earth in orbit around the sun and the ISS. I mean, it's all nonsense. It does not have that type of attractive. It's a small bias, and it is an incoherent type of magnetic field. This is exactly what how you could describe gravity. In other words, like I've been saying all this time, whatever you want to call it, this acceleration, whatever it is more of an electrical or electromagnetic type of phenomenon. And I firmly believe that without any doubt whatsoever.
Yeah. I mean, I mentioned the word gravity because, I mean, in the ball model, right, in their model, and that Newtonian kind of gravity, which is very different than what you're getting at here, which is much more into what we know nowadays.
Yeah, the Einstein description of gravity is just nonsense. It's bullshit.
Yeah, completely, man. It's and in my presentation I have this tiny video that Zach
but all I had was
present to the community, and here you can see how changing polarity, you can change the orientations and things like that. So when you start to put, like I said before, when you start to put all together, you can see how electrical fields and magnetic fields is more a nature that can explain everything,
I agree. I recognize that room. Hey, I'm right next to that room.
Oh man.
This was shot in my house.
Your house.
That's my house. That's funny. Yeah. Zach did that here.
So what's going on here? What's actually going on here in this experiment here? Or demonstration?
You have Bob, you can explain it.
Okay, what's happening is Zach is taking an electrostatic generator, and he is putting one polarity on the top, one polarity on the bottom, and it's a Van der Graaf generator is what it's actually called. And he's turning it on, and he's basically causing a static attraction, to one plate or the other. And if you reverse those polarities, it will change the attractive capabilities. So it was just something that he was demonstrating with the Van der Graaf generator. Because he's doing all these, electrical type of experiments here and magnetic type of experiments and showing the interaction between the two.
Yeah, it's almost like an inverted gravity that happens here with this piece of paper, if that's what it is.
Yeah, but instead of it necessarily being a charge potential, which I have kind of advocated for quite a while, but now that I'm looking at it, I'm seeing that it's more of an incoherent magnetic field, and that's something I'll have to explain on a different episode of Globebusters. But that in and of itself, which was explained to me by my good friend, the PhD electrical engineer, when he explained it, wow, did it make a lot of sense. But we'll go there on another episode.
You wanna stop sharing?
Sure. And then I have
can I make a couple of points about inversions that I think it's quite odd, because I'm not sure there is a physiological condition where the person sees upside down or the world seems upside down, but we know that in order to see what we see, things are getting inverted, right? We get these inverted images coming upside down right? It's odd. I'm just saying there's something happens in the eye that things get inverted, we get things upside down. And there's these stories from Aboriginal indigenous cultures in the Amazon. They talk about some of the cataclysms or some of the transformations of the world. There's this upside down thing that can happen where basically it's almost like if you get this you turned it upside down. Okay, so then suddenly the floor will be up, but physically in the whole thing. That's kind of part of their myths. I don't know if it's, I don't know where it comes from, but it is odd. It's almost like, like let's reshuffle this thing and start over. Then then the ground will go up and then everything will get reshuffled. I mean, that's kind of their idea. It's just quite striking transformation. Wow.
Okay, Eero, I'm going to cut the screen share. And I'm going to whip over to my screen share. Ben has a video. We're definitely at the end of the show, guys, but I do want to show Ben's 5-minute video that he just got rendered. So let me go ahead and share the correct screen here with you guys, and you should be able to see that. And then let me get the link to Ben's video. Bada bing. There it is. Okay. So, Ben, do you want to give us any introduction on this before I play it?
No, I just want to say thanks to Wide Awake. And I hopefully I didn't mess up anything. Didn't have a chance to review it too well, but I hope you enjoyed it, everybody.
Okay. Well, we'll forgive you if you did, so no problem. And before I play that, Eero, dude, absolutely fantastic presentation. I want to elaborate on this more. I definitely want to move forward with it, because this is something that, as far as a progression of logic into how this model works, makes perfect sense. And I think that, now that I'm understanding where you're going with this, I can kind of help, clarify it to our viewers. But, for those of you that may not have understood it fully, I did. And we're going to do this, where everybody can get it, because it is, wow. Brilliant. It's nothing short of brilliant. Eero, I love the way your mind works.
Amen. Thank you.
Also, I think this is the kind of thing that you're so familiar with this explanation that you crafted. Is a really good hypothesis for how things work. It's the kind of thing that you would put in a textbook and say, this is really a possibility.
And have in mind that when I explain this in Spanish, it's like really most understanding and with a lot of more
developed
explanation. For me, explaining in English is a little difficult, so that is why I really appreciate that someone like Bob trying to put all together. And of course you have all my material to uses, and anyone out there. My channel is called Null for Everyone because all my material is free for everyone. So I mean, anyone who wants my presentation with all this video, I can send it, no problem. In fact, in Dallas conference, a guy that at the time of the dinner, he came to me, Jack bring a guy to me to give some video, and then I didn't see again, so I can send it. So if that guy is listening right now, please contact me, and I send, because I say like I'm gonna bring my computer, my notebook, and I'm going to give the files, and then I didn't do it, and I forget, and at 4 a.m. in the morning I take the flight to return to Argentina, so I cannot do. I didn't do that. And
Bob, what if you're talking about Alex by any chance? Alex, the guy that has the terabytes and terabytes of archived stuff. What if you're talking about him?
Well, it could be. I mean, it's out there for everyone, and I really appreciate your, honest consideration and your words. And please, use my material, ask me whatever you want, because I really like to share this with, people that understand the flat Earth model and trying to put all together. And that's the idea.
I wonder if, Bob, this wouldn't be something that is right up the alley of Sandor and some of the other people at FEIC, in that you could make a bridge between the argument and the hypothesis that Eero is going with the different elements and how it comes together. and they can then inquire into it and come up with it can even be a presentation later that we all could work with, because there's highly capable people there that really know the flight, exactly what you just said, Iru.
I think absolutely. I know everybody in FE-Core watches this show, and so I will be anxious to see the chatter in the FE-Core Skype group afterwards. But this is exactly the kind of stuff that we want to look into and research. And Iru has really done some groundbreaking work on this. And I mean, I get it. I totally get where he came from. I was fascinated when he presented this, in Dallas, and that's why I wanted to cover it more today. But yikes, good stuff, man.
Yeah, there's so many aspects that if Iru, this can be organized in an English presentation or a scripted kind of video.
That is your part, man.
Well, if we can talk about or get the footage, and with I'll be glad to do it. I'll be happy to do it and make sure that it has all the elements that are needed for all the parts. Absolutely, it's something worth pursuing, of course.
Okay. All right, guys. So I'm going to go ahead and play Ben's video, and then we will wrap it up. So this is a 4-minute video that Ben just finished rendering. And it highlights Dave Wide Awake's work. And here we go, guys. Let's give it a listen.
Welcome, everyone. The conference season is over, and I'm back doing what I love. For this video, we're going to analyze some amazing new footage from Wide Awake taken off of the western coast of Florida. It's probably Wide Awake's best footage to date. The foundation of the flat Earth is observable, testable, and repeatable experiments that everyone can perform, and the Bible agrees. Prove all things, hold fast that which is good. You don't have to be a Christian to know that's excellent advice for everyone, and that is exactly where our phony mainstream science has failed humanity. And that's what we're going to do today. Prove all things. You're going to see unequivocal proof that there is no curvature, ergo the Earth is flat. We're going to use both the distance to the horizon and the target hidden height calculations to debunk the globe myth today. My friend Wide Awake's camera was only 5 feet above the water. Here is Wide Awake's cell phone footage capturing the fact that he was indeed filming the Cutter Rock bird rack as shown on the screen of the Nikon P1000, which we'll be taking a much closer look at. I've included Wide Awake's camera coordinates as well. I grabbed the coordinates of Cutter Rock from this government brochure. Like all of the bird racks, Cutter Rock is only 16 feet high. According to Google Earth, Cutter Rock was a huge 11.22 miles away from Wide Awake. Even this sunset footage shouldn't be possible on the globe. Do you think you'd see the reflection of the sun like this on bendy water and over curvature humps? And we can also use the sunlight reflection on the water to mark the apparent horizon as well. But let's get to the evidence. Let's freeze the frame here. That is Cutter Rock on the left, a tiny boat on the right, and a closer boat in front. The footage is just awesome. Let's freeze it again. This is at full zoom on the P1000. If you remember, Cutter Rock was 11.22 miles away from the camera. What I also love about this frame is the tiny boat next to Cutter Rock. The boat appears to be even further than 11.22 miles because the base of the boat is higher perspectively than the base of Cutter Rock. Look at how tiny that boat is. Let's first look at the target hidden height calculation. According to the globe math, 48 feet should be hidden behind the curvature. In other words, this is what it should roughly look like if we lived on an imaginary globe. But we don't see that curvature hump in any manner, and there is no distortion accounting for selective curvature hopping mirages. But the globe horizon test is my favorite. Under the globe model, at an observation height of 5 feet, the horizon could not be further than a mere 2.7 miles. But the actual apparent horizon here is further than 12 miles. There's simply no way that this footage is possible on a globe. did the huge bulge of water in front of the bird rack magically and selectively disappear and then reappear miles beyond the rack, all without affecting the rack itself? The globe claim is nonsense. The evidence is overwhelming. We don't live on a spinning ball, vortexing through the vacuum of space at millions of miles per hour. The Earth is flat and stationary. And the truth is the only way that we can all be free. So please, share it everywhere you can because our time is limited. I don't think taboo conspiracy is going to be considered commercially viable. Thank you.
Wow. Yeah. Amen to that. That's another thing we need to, keep in mind. YouTube has set the stage to delete us all. And
it's frightening, isn't it?
Yeah, it's ridiculous.
Does Globebusters have an alternative route yet? Like BitChute or something?
I have a few different accounts set up on different platforms. However, I'm not exactly sure which one we're going to commit to. I also have other channels as well on Globebusters. We have the Globebusters 2, Globebusters 24/7, etc. But I think if they start taking us down, they're going to take us all down. And again, this should tell people something. If you are on the fence, you have to ask yourself why. Why, if Flat Earth is such a silly thing, why is it such a threat to the powers that be where they literally have to destroy their own revenues and completely take down their platform for free speech to hide a bunch of silly flat earthers, right? Think about that, people. So, all right. Okay, so I think that will probably be it for a show today. We've got, I had a few other things I'll cover, but I'll cover them next week.
I want to see that projection in the middle air that you mentioned before. That's a glass dome thing with you can project an image, something like that. You talk about it.
What Chris Pontius had with the star in the middle.
Oh, that?
Yeah, I never saw that.
Oh, you didn't see it?
No, I didn't see it.
Let's.
No. Okay. You show maybe when I was outside my house and.
Okay. Here, I'll just go ahead and play it. I'll just play the video. It's only 2.5 minutes.
Okay, play the video and then without sound if you want.
Yeah, this is what I said that you have modeled as well in your. Maybe you didn't hear that. That's why I didn't comment because it's similar to the model that you made with the sun going over the kind of glass just like this, and the sun being projected from the inside in different positions. But this is kind of like an actual demonstration of how that would work.
Okay, here we go. Yeah, and I'll go ahead and put the sound on really quick. I think it's just us chattering.
Oh, there it is again. Whoa, look at that.
Whoa, you're right.
It's like you got your hand behind it.
It's taking the light and
no way.
Right here in front of me.
Yeah.
You see it?
Wow.
Yeah, you can see it from every angle.
Every angle.
That's it, Cammy.
Around out here,
this is it.
It's unbelievable.
So
that is
the lights.
Look at this.
Wow.
Floating. It's just floating there.
Oh, what is this? A hologram. There's another hologram down there.
Wait, keep doing it, guys. Keep doing it.
Right here.
Oh, yeah.
See my,
it's just what you're
and then it goes away. You got to be at the. Wow.
That's what the sun and moon are doing.
Yeah.
Apparently
so. It's the apparent.
Yeah.
Exactly.
Yeah,
exactly, gentlemen. Oh, yeah.
The YouTube picture, though.
It's the parent.
So you can obviously tell a bunch of nerds in utter amazement over this, but this is just so cool, because it's nothing more than a clear plastic parabola, and we'll show at the end here that this star that it's projecting out holographically is just an ornament on the wall. It's a light and it's lit up. But the astounding thing about it is, like, the further you get away from this thing, the more 3D it becomes. I mean, it's absolutely astounding, the clarity and how perfectly you can see it, seemingly just hanging there in space. It's absolutely bizarre, and it doesn't matter what angle you look at it from. You get this amazing representation of the star on the wall. And I
wonder what happens if you turn this to the sky at night, and what would happen. Just curious if there other lights.
There is also the other technology called helioprojection that you can project on the gas. so helium gas or you know, vaporized water, things like that. So you know, when you put all together, for example, the presentation that I did, and you start seeing like well, will be really nice to have a rocket up there with the special conditions on the camera to show if there is possible to be the density enough to project light, or maybe that medium that is electrical insulator maybe doesn't even allow to project light. I don't know, you know, I just paraphrasing it, but you need a medium all the time. You need some kind of medium. There is no emptiness, vacuum. You cannot have properties there is no medium, you know. That at least is all things that you're trying to prove. You always need some kind of medium.
Absolutely. So, and then there it is hanging on the wall back there. And that's all it is. And, you know, from that, we get this. It's just mind-boggling. Nice. Yeah. So, all right, cool. Well, I'll go around one more time, and we'll let you guys have your last words. And Rodrigo, we will start with you. You have anything coming up this week that is of interest to anyone?
Thank you so much, Bob. Thank you so much.